First up, the Reynolds number, symbol Re. This is arguably the most important dimensionless number in fluid mechanics, named after Osborne Reynolds, who discovered it in 1883. What does it tell us? Reynolds number quantifies the battle between two forces in a flowing fluid. Inertial force, the force of the fluid that results from its motion, think momentum, the fluid wants to keep moving. Viscous force, the force of friction within the fluid. Think of it as the fluid's internal resistance, its stickiness. This tries to slow the flow down. Reynolds number equals inertial force divided by viscous force. The formula, Re equals rho times V times L divided by mu. Or equivalently, Re equals V times L divided by nu, where rho equals fluid density, V equals velocity of flow, L equals characteristic length, like pipe diameter, mu equals dynamic viscosity, nu equals kinematic viscosity, which is mu divided by rho. Physical meaning: when Re is high, inertial forces dominate, flow is energetic and chaotic, turbulent flow. When Re is low, viscous forces dominate, flow is smooth and orderly, laminar flow. The critical values, memorize these. For flow inside circular pipes, Re less than 2,300, laminar flow, smooth, predictable, layers slide over each other. 2,300 less than Re less than 4,000, transition zone, unstable, unpredictable. Re greater than 4,000, turbulent flow, chaotic, mixing, swirling eddies. Most industrial piping systems operate in the turbulent regime because turbulent flow provides better heat transfer and mixing. Critical Reynolds number. This is the Re value where flow transitions from laminar to turbulent. For circular pipes, it's approximately 2,300. But remember, this value changes for different geometries. A flat plate has a different critical Re than a pipe. Quick check. Notice Re has no units. Density times velocity times length divided by viscosity, all units cancel out. That's what makes it dimensionless and universal.